Hello there, friends and neighbors. Now I'm going to show you how to write a complete results section for a two-sample t-test. We've got a categorical variable, which in this case is whether or not you have a pet, and a quantitative outcome variable, which is how happy are you on a, I think they used a 5-point scale. So I've already imported the data. It's team K4, K to the 4th, that's the name of the team. I've imported it and I'm ready to rock. So all results sections, your typical results section is going to have all of these components, and for our introductory class, all of our results sections are going to be required to have descriptive statistics, a graph, and the inferential statistics. The inferentials must have a null, hypothesis, alternative, and alpha, the assumption check, the confidence interval, test statistic, degrees of freedom, p-value, decision about HO, an interpretation of the CI, and then finally, interpretation in plain English for the research context. So let's go ahead and get started. First, we want our descriptive stats. Go statistical analysis, continuous variables, because the outcome variable is quantitative. We treat quantitative variables as continuous. So how happy are you is the question. Numerical summaries. I'm going to look at a person's happiness. I'm going to summarize it by whether or not they have pets. Okay? Okay. So for the yes group, we see a mean of 3.75 in the sample. I'm sorry, for the no group, mean of 3.75. For the yes group, a mean of 4.46. I'm going to just copy this table. Right-click, copy. Come to my Word document. Delete that. Right-click, paste. Paste. And then it's a nice idea if you've got a table like this, select it and choose a monospace font so it doesn't look so ugly. So you choose, let's say, Courier New. And then it will look nice. Give it a tab. Wait a second here. I'm going to do that again. Copy an extra line helps to make it look nice. Copy. Paste. Select it all. Make it a monospace like Courier New. I don't need that ES. Get rid of that. And there we go. Got your means, standard deviations. Sample sizes are 4 and 26. Now, we don't meet the assumptions here. Okay, next I'm going to want a graph, but the graph is actually automatically output by the analysis. So I'm going to jump ahead here. So their null hypothesis is that that having a pet has no bearing on whether or not you're happy. So in other words, mu for pet minus mu for no pet is equal to 0. There's no difference. Against the alternative hypothesis that mu for pet minus mu for no pet. Now they think that people who have a pet are happier. So it's actually going to be the difference is a big number minus a little number is going to be greater than 0. So you might change the null hypothesis to say less than or equal to. Okay. And then for your alpha, I'm going to choose 0.05 because that's the typical one. Okay, now the graph, again, we're going to get that in just a moment. Now the assumption check. The assumption for a two-sample t-test is that both groups have the variable that is normally distributed or n at least 30. And as you can see, the n's are 4 and 26, so that's too small. Now to check the assumptions, I'm going to make a graph, graphs and tables, histogram of happiness. Just look at it. And of course it does not look even a little bit normally distributed. It is skewed left. And I'm going to just acknowledge that. The variable is not normal. And n is too small for both groups. So we do not meet the assumption. But this is a class project, so we're going to go ahead and do the analysis anyway. Okay, so I'm going to go ahead and get my confidence interval, test statistic, degrees of freedom, p-value, and also the graph while we're at it. I'm going to put this away. Okay, You know, in a more formal class, you would actually need to formally test normality, and keeping that graph would be part of that. But I'm going to keep it simple here. Statistical analysis, continuous variables, because the outcome is quantitative. Two-sample t-test. Response variable is happiness. Grouping variable is pets. Now, the difference is no minus yes. And so they're hypothesizing that you have more happiness with yes. So it's going to be a small number minus a big number, which is to say that it is left tail. In other words, this is written the opposite of the way I have written my question here. So I'm going to rewrite this just to make it easy to understand. No pet. Pet is greater than or equal to 0. Whereas no pet minus pet, that's small happiness minus big happiness, you're going to have it less than 0. Okay, so that's what their hypothesis is. Notice that that's equivalent, and if you swap them, it doesn't make any difference as long as you change the direction of the sign. Anyway, now I'm going to click OK. It is actually appropriate to also choose, you could choose the Welch test, but I'm going to run it as an ordinary t-test, which has more strict assumptions. We're going to ignore it for now, though. Click OK. There's my graph, which I'm going to capture. If you have a Windows machine or Mac, you can just right-click on this and save it or copy it. I don't. I'm using Linux, and so I'm going to do this a little bit differently. I'm going to paste it into a graphics editor. And cut out the clip that way. Copy clipboard. Okay. Tools, selection, rectangular select. And this is just because I don't use Windows or Mac. So mine acts a little bit differently from what yours is going to be. Alright, so now I'm going to put that graph in here, right here, where I wanted the graph. Okay. Paste special. I just paste it. And right click, anchor as character, make it smaller. Okay. Cut, paste, cancel, and there we go. So I've got my descriptive statistics, I've got my graph, I've got my HO, H1 alpha, I've got my assumption check. We will proceed anyway. Now, confidence interval, all this stuff is here in my R output. I'm going to scroll up so we get to the good stuff. Here it is. There's the T, negative 1.93, or 93. 28 degrees of freedom. There's my p-value. Copy all of that. Paste it. Get my 95% confidence interval, and you'll notice it has negative infinity on one side. That's because this is a one-tail alternative. So what we're actually looking at is this difference less than 0. And so we're seeing what it is at most, and it is at most negative 0.08. So I'm going to make my decisions now. Okay, since my p-value is less than or equal to alpha, so we reject HO. We are 95% confident that the population mean difference is at most negative 0.08. Right? So that means I'm sure that's because this interval does not include 0, that in fact, yes, people are happier if they've got a pet. So that's what that means. Evidence supports the claim that people are happier with a pet because the population mean difference, no pet minus pet, that difference, we're pretty sure, we're 95% sure that difference is less than 0 in the population. Okay, that's a complete results section. That's what they look like. You've got your descriptives, you've got your graph, HO, H1 alpha, assumption check, the mathy fun stuff, decision about HO, and interpretation into plain garden variety English.